Okay, Geometry Kids, what we're going to work on today is right triangle symmetry. I know that sounds like a lot, but it's really not. And what this is this is a further continuation of our discussion on not only just similarity, but the application of the Pythagorean theorem to that. So last time we learned that if we have a right triangle, the sides will always be in the ratio of a squared plus b squared equals c squared, where a and b are the legs that form the 90-degree angle, and c is the hypotenuse. So one of the Pythagorean triplets that we learned about was 3, 4, 5. Okay? And then we also learned that multiples of that would always have the same thing. So 6, 8, 10, or we could go, let's say, 9, 12, 15. But notice, though, even though they are different, that the ratio stays the same. The basic ratio, here we have 3 to 4 to 5. And so even if we did 9 to 12 to 15 here, if we pull the 3 out of each of them, 3 times 3 is 9, 12 divided by 3 is 4, and 15 divided by 3 is 5. So see here how that basic ratio is still identical. So that is true not only for this triangle, a 3, 4, 5 triangle, a 6, 8, 10 triangle, a 30, 40, 50 triangle, a 300, 400, 500 triangle. And if you remember from similarity, one of the types of similarity we had was side, side, side similarity. Which means that because I know that the sides maintain that ratio, that the two triangles are similar. So I know that these two triangles are similar to each other. And if you remember the definition of similarity, is that the angles are identical and the sides are proportionate. So again, the angles are identical and the sides are proportionate. And that is key. That is the basis for all right angle studies right there. Is the belief that, or the knowledge that rather, because it's not a belief, it's proven, that in a right triangle, if we know that the sides are proportionate, then the angles have to be identical. Likewise, if we know that the angles are identical, then the sides must be proportionate. So that leads us to what are called special right triangles. We're going to go over one today and one on Tuesday. Today is Tuesday, so let's go over the other one on Thursday. I say this kind of tongue-in-cheek. No one shows up to my lessons. I doubt any of you actually watch the entire videos, so this is really just me talking to myself and my computer in an empty room for the benefit of no one. Okay, so if we have a square, okay, so here be a square, and we cut that square in half. We now have two separate right triangles. I'm going to keep that color. That's not the right color. We have this right triangle right here. And we of that right triangle right there. Now I know that they're not exactly the same size, but we're going to pretend that they are. So they're both right triangles. And these are isosceles right triangles. How do we know they're isosceles? Well, two of the sides are the same. So these are isosceles right triangles. Pause for a drink of water. And I'm back and adequately hydrated. Okay, so isosceles right triangles. So let's pretend that this square had sides of 1. Okay? So we know that a squared plus b squared equals c squared. We talked about finding the hypotenuse as being c equals the square root of a squared plus b squared. So c would equal the square root of 1 squared plus 1 squared. C equals the square root of 1 plus 1. Or c equals the square root of 2. So that gives us, in an isosceles right triangle, a leg to hypotenuse ratio of 1 to 1 to the square root of 2. Now, because this is an isosceles right triangle, we also know that these two angles are the same. So this, you'll hear different people call it different things. You'll hear it referred to as an isosceles right triangle. You'll also hear it referred to as a 45-45-90 triangle. Because I know that if this is 90 degrees right here, this angle up in the top, and all three of them have to add up to 180 degrees, well, that means that these two angles down here have to add up to 90 degrees. Because it's an isosceles triangle, we know that the base angles have to be congruent. So we go 90 divided by 2 and get 45. So this is 90, this is 45, this is 45. So this is called an isosceles right triangle, or a 45-45-90 triangle. And it has a basic ratio of 1 to 1 to the square root of 2. So let's put that to the test. So here we have a much larger triangle. So let's say that this is 10 and 10. And we want to find out what the hypotenuse is. Well, we know that the hypotenuse is going to be C. 10 equals A. 10 equals B. That looks like a 90 because I drew the A there. So that gives us C, which is the hypotenuse, is equal to 10 squared plus 10 squared. That gives us the square root of 100 plus 100, or the square root of 200. So, I would recommend that you guys all go and watch the video I did for my integrated math class. It's called Radicals and Factoring. That'll help here. So what we're going to do here is we're going to find the prime factorization of this. So we're going to pull out prime numbers. We're going to pull out a 2, so we end up with 2 and 100. Oh, we can pull out another 2. 2 and 50. Pull out another 2. 2 and 25. Okay, so we have no more 2s, but we can break that down into 5 and 5. Now, when you're factoring out a radical, which this is, you need to be able to pull out pairs, okay? So it's the square root. So we know that this is 4 times 2 times 25 is what we basically just showed. Well, we can break down the square root of 4 times 2 times 25 to the square root of 4 times the square root of 2 times the square root of 25. So that gives us the square root of 4 is 2. Square root of 2 is just 2. Square root of 25 is 5. 5 times 2 is 10. So we end up with 10 times the square root of 2. So notice here the ratio of the legs, 10 to 10 to 10 radical 2, is exactly the same as over here, 1 to 1 to the square root of 2. The legs are the same, and the hypotenuse is the length of the leg times the square root of 2. So let's write that down. So we have isosceles, right triangles. Okay? So we know the ratio of leg to leg to hypotenuse is 1 to 1 to the square root of 2. Which means that the length of one leg equals the length of the other leg. And the length of the hypotenuse is equal to the leg times the square root of 2. Okay, so we can actually use these now to find missing parts. So if I was to use A, B, and C here, this would be A equals B, and C equals A radical 2, or B radical 2. Put both of them down just to be overly cautious, but they really are the same thing. So before we get going, there's one more thing we need to go over, and that is rationalizing denominators. So let's say that I have this nifty triangle right here, and I know that's A and that's B, and I have, let's say, 7 is my hypotenuse. Well, we just learned that the hypotenuse equals the leg times the square root of 2. So I know that 7 equals A times the square root of 2. Well, what would I do here? I would divide by the square root of 2, and that would give me the leg length of A equals 7 over the square root of 2. Now, that is numerically correct, but mathematically, this is difficult because it has what is called an irrational denominator. And so what we want to do is rationalize the denominator. We want to make sure the denominator is in rational form. Now, it doesn't affect us that much here in geometry per se. We've gone through high school. But mathematically, trying to lug around, especially if you ever have to add, subtract, multiply, divide fractions, which happens all the time, if you have an irrational denominator, then the problem just gets harder and harder and harder. By rationalizing the denominator, we're making our lives easier. So this is what we're going to do. We're going to take this 7 over the square root of 2, and we're going to multiply it by 1. Because in multiplying it by 1, we don't change its value at all. And that's important. We don't want to change its value. But what we can do is change its form. So we're going to multiply this by the square root of 2 over the square root of 2. Notice that because I'm putting the square root of 2 over itself, that equals 1. And then I'm going to multiply. So that gives me 7 radical 2 over, and just so you guys, in case you didn't know, the square root of 2 times the square root of 2 equals 2. And that's because the square root of 2 times the square root of 2 equals the square root of 4. And the square root of 4 equals 2. So when I have these two together, that's just 2. So that is my leg length. So A and B equals 7 radical 2 over 2. Okay, so on Thursday, we are going to go over 30, 60, 90 right triangles, the other type of special right triangle, and we will also answer any questions you have about this. And I will probably give you guys some sort of assignment, ungraded, of course, but some sort of assignment which helps you practice these skills. Thank you very much, you guys. Stay safe, stay sane.